prove that integral Pn star of x, Pn of x dx equal to 2 divided by 2n plus 1. To prove this, consider the Legendre equation, that is d by dx of one minus x square dy by dx plus n into n plus 1 into y equal to 0. Using the polynomials, Pn of x and Pm of x, we have to develop Legendre equations. If you use Pn of x, you may get d by dx of 1 minus x square d Pn of x divided by dx plus n into n plus 1 Pn of x equal to 0. So this is equation 1. The same manner, d by dx of 1 minus x square dPm of x divided by dx plus m into m plus 1 Pm of x equal to 0. This is equation 2. Now, multiply equation 1 by Pm of x. You may get Pm of x d by dx of 1 minus x square dPn of x divided by dx plus Pm of x n into n plus 1 Pn of x equal to 0. This is equation 3. Then multiply equation 2 by Pn of x. You can get Pn of x d by dx of 1 minus x square dPm of x divided by dx plus Pn of x m into m plus 1 Pm of x equal to 0. This is equation 4. Now find out equation 3 minus 4 gives Pm of x d by dx of 1 minus x square dPn of x divided by dx minus Pn of x d by dx of 1 minus x square dPn of x divided by dx. Just this term minus this term. Then plus Pn of x to Pm of x n into n plus 1 minus m into m plus 1 entire equal to 0. This is equation 5. Just we have subtracted this term from this. We have taken out Pn of x into Pm of x as a common term. Then n into n plus 1 minus m into n plus 1. But n into n plus 1 minus m into m plus 1 equal to n square plus n minus m square minus n. is equal to n square minus m square plus n minus m. M is equal to n plus m into n minus m plus n minus m. N square minus m square is n plus m into n minus m, which is equal to n minus m into n plus m plus 1. So instead of this term, we have to put this. Now equation 5 becomes Pn of x d by dx of 1 minus x square dPn of x divided by dx. So this is equation 5. Pm of x, there is Pm Pm of x d by dx of 1 minus x square dPn x by dx minus Pn of x d by dx of 1 minus x square dPn of x divided by dx plus Pn of x into Pm of x n minus m into n plus m plus 1. Entire is equal to 0. So this is equation 6. So this is Pm of x d by dx into 1 minus x square minus this term Pn of x d by dx of 1 minus x square dPm of x. This is m here also you have to put m. Now we have to integrate equation 6 with respect to dx. Integral Pm of x d by dx 1 minus x square dPn of x divided by dx into dx minus integral Pn of x d by dx of 1 minus x square dPm of x divided by dx into dx plus n minus m into n plus 1 Pn of x Pm of x into dx equal to 0. This is equation 7. We are going to vary from minus 1 to plus 1, minus 1 to plus 1, minus 1 to plus 1. Now you have to integrate this equation 7 by parts. For that, here this is u, this is dv. Integral u dv equal to uv minus integral v du. We have to use this formula. Now we have to integrate this first integral. Consider the first integral u dv. U is Pm of x. dv is this much. So uv, that is pm of x. This is dv. V is dx, dx cancel. If you integrate, d is also removed. So the terms present inside the bracket is v. 1 minus x square dp n of x divided by dx. Now apply the limit. Minus 1 to plus 1. Then minus of integral v. V is 1 minus x square into dp n of x divided by dx. This is v. du. U is pm of x. Du is dp m of x divided by dx into dx. Minus 1 to plus 1. This is the value of the first integral. Now we have to come to the second integral. Yes, we have to integrate this using the same formula. Integral u dv equal to uv minus v du. Here this is u, and the rest of the things, this is dv. Put the negative sign. Write down the value of uv, that is pn of x into 1 minus x square dp m of x divided by dx. Minus 1 to plus 1 minus integral v du. Value of v is 1 minus x square dp m of x divided by dx. V du, that is dpn by dx into dx. This is the value of du. Now we have to integrate the final term. This one plus n minus m into n plus m plus 1 integral of pn of x pm of x into dx. Entire is equal to 0. Here the limit varying from minus 1 to plus 1. Now we have to close the bracket here. Because this negative sign is common to all. Say this is equation 8. In equation 8, see 1 minus x square, the lower limit is minus 1, upper limit is plus 1. This is 0. This value is 0. Then consider rest of the integrals. Say this integral value is 0. This is in terms of minus. Here this is in terms of minus. This minus is commonly present, so minus into minus plus. So that you may cancel these two integrals here. Minus of dpm by dx 1 minus x square dpn of x by dx into dx. Here 1 minus is present, here 1 minus is present, minus into minus plus. So these two integrals are cancelled. This is in minus, this is in plus, 0. If you apply the limits plus 1 and minus 1, this is 0. This is also 0. Therefore, the only term left out is n minus m to n plus m plus 1 integral minus 1 to plus 1 pn of x into pm of x dx equal to 0. Say this is equation 9. In equation 9, say this is an important equation. Using this equation 9, we have to provide the interpretation. If n equal to m, integral Pn of x into Pm of x into dx not equal to 0. If n is equal to m, this quantity equal to 0. That means n minus m into n plus m plus 1 equal to 0. But this is not equal to 0. Integral value not equal to 0. Integral minus 1 to plus 1 not equal to 0. If n not equal to m, n minus m into n plus m plus 1 not equal to 0, but Pn of x into Pm of x dx equal to 0. If n not equal to m, this integral is equal to 0. These are all the two conditions we have arrived. I will go to the next part, generating function. We may express our Legendre polynomial in terms of generating function 1 minus 2xz plus z square power minus half, which is equal to summation over n equal to 0 to infinity z power n into Pn of x. Say this is equation 10. This is called the generating function. We have expressed Pn of x in terms of generating function 1 minus 2xz plus z square power minus half. In the same manner, we can write 1 minus 2xz plus z square power minus half equal to summation over m equal to 0 to infinity z power m into Pm of x. Now from the equations 10 and 11, multiply these two things. 1 minus 2xz plus z square power minus 1 equal to z power n into Pn of x into z power m into Pm of x, which is equal to z power 2n Pn square of x, where n is equal to 0 to infinity, plus z power m plus n into Pn of x into Pm of x. Here m not equal to n. Here m is equal to n. If m is equal to n, z power n into Pn of x plus z power n into Pn of x, that is equal to, we may write this z power n into Pn of x into z power n into Pn of x, that is z power 2n Pn square of x, plus another one possibility is m not equal to n. If m not equal to n, z power n into z power m, that is equal to z power m plus n into Pn of x into Pm of x. So that this is separated into two components. Here we have to use two summations, m equal to 0 to infinity, n equal to 0 to infinity, but m not equal to n. Now this is equation 12. Just integrate this equation 12. 1 minus 2xz plus z square minus 1 into dx and going from minus 1 to plus 1, which is equal to z power 2n pn square of x into dx plus z power m plus n integral pn of x into pm of x, where m not equal to n, where m is equal to n equal to 0 to infinity. Here also the same things. Already we have proved that the value of pn of x, pm of x, interval limit varying from minus 1 to plus 1 is 0 if m not equal to n, from equation 9. From equation 9. Therefore, the above equation is 13 is modified as dx divided by 1 minus 2xz plus z square. For minus 1 is written as dx divided by this quantity, minus 1 to plus 1, which is equal to n equal to 0 to infinity z power 2n pn square of x into dx, here minus 1 to plus 1. Now integrate this, we can get minus 1 by 2z log of 1 minus 2xz plus z square, limit varying from minus 1 to plus 1, which is equal to z power 2n minus 1 to plus 1 pn square of x into dx. So here, take this minus 2z. If you differentiate this, you can get minus 2z into dx. If you differentiate a quantity and then if you get the numerator, the formula is log of the denominator. The differentiation of this denominator is equal to numerator, because minus 2z is a constant you have taken out. If you differentiate x, you can get the numerator dx. Therefore, the integral of this quantity is minus 1 divided by 2z into log of this denominator. Now apply the limits. This is equal to minus 1 divided by 2z log 1 minus 2z. Instead of x, you have to put plus 1 plus z square minus log 1 minus, instead of x, you have to put minus 1. 1 plus 2z plus z square, which is equal to z power 2n minus 1 to plus 1 pn square of x into dx. This is equal to minus 1 by 2z log 1 minus z whole square minus log 1 plus z whole square is equal to z power 2n integral pn square of x into dx, limit varying from minus 1 to plus 1. Now take this negative sign internally. This is modified as 1 by 2z log 1 plus z whole square minus log 1 minus z whole square. This is equal to z power 2n minus 1 to plus 1 pn square of x into dx. Now this is 1 divided by 2z, 2 log 1 plus z minus minus 2 log 1 minus z equal to z power 2n minus 1 2 plus 1 t1 square of x into dx. Take these two outside, you may get 1 divided by z into log 1 plus z minus log 1 minus z equal to z power 2n minus 1 2 plus 1 p1 square of x into dx. Now we may write 1 by z minus z square by 2 plus z cube by 3 minus z power 5 by 5, and the series is going on. Then we have to put this 1 by z is common, minus of minus z minus z square by 2 minus z cube by 3 minus z power 5 by 5, and the series is going on. The entire is equal to z power 2n integral minus 1 to plus 1 p1 square of x into dx. Now you have to modify them. See, this is 1 by z. Now you have to combine z minus z, that is 2z minus z square by 2. See this minus of here minus z square plus. So these two terms are cancelled out. This is minus z square by 2. This is plus z square by 2. So cancelled out. Z cube by 3 minus of this minus and minus plus 2 z cube by 3. Here one correction that to provide is here also you have to change z minus z square by 2 plus z cube by minus z power 4 by 4 plus z power 5 by 5. Here minus z square by 2 minus z power 4 by 4 minus z power 5 by 5. In this way the series is going on. Here also minus, not plus. Continuous minus. Say z minus into minus z, that is equal to plus z. So 2z minus z square by 2 plus minus into minus plus z square by 2, 0. Z cube by 3 minus into minus plus z cube by 3, that is 2z cube by 3 minus z power 4, then minus into minus plus z power 4 cancelled out. Z power 5 by 5 minus into minus plus z power 5. This is plus 2z power 5 by 5. In this way, this is going on. We may put z power 2n into minus 1 to plus 1 pn square of x into dx. Now take these two outside. 2 divided by z to 1 plus not 1, this is z we have taken out just two outside. Z plus Z cube by 3 plus Z power 5 by 5. Then the last term is Z power 2n plus 1 divided by 2n plus 1, which is equal to Z power 2n minus 1 2 plus 1 p1 square of x into dx. Here expansion of log 1 plus z is z minus z square by 2 plus z cube by 3 minus z power 4 by 4 plus z power 5 by 5, and then the series is going on. Next term is minus. Then log 1 minus z is minus z square by 2 minus z cube by 3 minus z power 4 by 4 minus z power 5 by 5. Then this is also minus. The next term is minus z power 6 by 6. Then if you align these two, you can get this term. Here if you put n is equal to 0, then z power 1 divided by 1. You may get the first term. If you put n is equal to 1, we can get z cube divided by 3, the next term. Say this is equation number 14. Now from equation 14, we have to write take the equation 14, 2 by z 2 by z z plus z plus z cube by 3 plus z power 5 by 5 z power 2n plus 1 divided by 2n plus 1, which is equal to z power 2n integral pn square of x into dx minus 1 to plus 1. This is equation number 14. Now this is modified as 2 into 1 plus z square by 3 plus z power 4 by 5 plus z power 2n divided by 2n plus 1. So this is equation 14. Just we have divided equation 14. The left hand side of equation 14 is divided by z. So if you bring this z by z is 1. Z cube by z is z square by 3. Z power 5 by z is z power 4. Z power 2n plus 1 by z is z power 2n. This is equal to z power 2n pn square of x into dx, going from minus 1 to plus 1. So this is equation number 15. Now compare the coefficient of z power 2n. If you compare the coefficient of z power 2n, you may get Pn square of x into dx equal to 2 divided by 2n plus 1. See this. Here the power is this much. 2 divided by 2n plus 1. Just here the coefficient of 2 z power 2n is Pn square of x into dx. So this is actually Pn star of x into Pn of x into dx, which is equal to 2 divided by 2n plus 1. Now entire is given in a single form, that is Pm of x into Pn of x into dx, which is equal to 2 divided by 2n plus 1 into delta of m comma n. If m is equal to n, we can get Pn square of x into dx, which is equal to 2 divided by 2n plus 1. If m is equal to n, delta mn is equal to 1, because this is Kronecker delta. If m not equal to n, delta mn is equal to 0, therefore Pm of x into Pn of x into dx equal to 0. So we have arrived at this condition, Pn square of x dx equal to 2 divided by 2n plus 1. This is equal to Pn star of x into Pn of x into dx, because Pn square of x equal to Pn star of x into Pn of x. Hence we have proved